we will be doing the literature review, we will be doing related things. So I'm exploring some kind of AI technologies and such kind of things today. So let's try what kind of things do we have. Let's open some Gemini AI. I will be using this. Okay. Oh, it says I have Gemini app, so I can use that Gemini app as well. So let's call it if we take help of YouTube and we ask the dynamic gesture dynamic hand gesture recognition, you will find a lot of videos. So Here are the application of template matching algorithm for dynamic gesture recognition. So a template matching is a very a very common way of classification. So if you are just starting out and want to do a very simple thing, you can do the template matching. I'm not sure what this video will apply the templates. Maybe they created all the images and combined them together and then compare the templates. This idea is not so good. And if we yes, there are the other hand gesture techniques, and similarly, this is also one of the most popular technique where you create the hand points with the media pipe library and then you apply the hand gesture recognition. So let's see what this is. So this is also some kind of research topic on this, and here you can see one example of the gesture recognition where you create a point map of your hand and you display some compare the static gestures. These are all examples of static gestures, hand gestures. So uh, this point cloud that you are uh, seeing here, the red dots, this is created with the media pipe library. So if you want to do some similar thing, you need to use a media pipe library. Media pipe library, you may face problem setting up in your Raspberry Pi. So if you are doing this computer vision related project in your Raspberry Pi, the media pipe could be some headache and you may need some more memory in your Raspberry Pi, like 8 GB or 4 GB. This could be tedious to set up in your Raspberry Pi as well. So you need to keep that in mind as well. So let's get back to our Google Scholar, and let's see what we do have here. So we will study the gesture recognition, and the first paper is a survey. The application of gesture recognition are manifold and ranging. Let's try some AI tool for researching and see how much it can help. So if we go to the consensus AI, here it is. So I find the consensus AI very helpful. I had tried it, so I find this AI tool very helpful in your initial comparative study. So kind of hand gestures recognition, I don't know, maybe let's add research gap as well, and see what the consensus shows us. This app is very good when you do your initial research. Why study the research papers if you are not familiar with this concept? So you need to study the research paper rather than doing a Google search when you are selecting your project, is because you need to find out the real academia, what they are doing, what the research is going on, and where you can actually put your input. So how you can be a beneficial for the research community. This way, if you really read the research papers rather than just YouTubing and Googling stuff, rather than just focus on a research paper reading and do some literature review. It will help you to find out what the problems people are facing, how much the work they had done. You may learn some new techniques, how they done certain things. So it is my way of researching the project, and many more researchers. This is a common academia thing. And let's see what we get the output. A review of hand gesture recognition system current progress. It says that the vision based hand gesture recognition research shows promising progress, but more work is needed for practical systems. So this paper summarized that the vision based gesture, well, this says this opens up a new question, which is when you are doing vision based gesture recognition, it means that there are other kind of gesture recognition techniques as well. We had studied other gesture recognition techniques in some of our previous streams, where we were studying the MPU 6050 based the research we had discussed there as well. So let's see what study snapshot they come up with. Method is semantic review, and outcomes are recognition activity. Signer dependent system had average recognition accuracy of 88.8, while Signer independent systems average are 78.2. So if you follow up the same thing and you come up with a higher accuracy, this will be a good contribution. This paper is cited 26 times, and it is published in 2021. So it is pretty recent paper, and pretty good citations it has. Then we have a systematic review on hand gesture recognition techniques, challenges, the surface electromyography sensors. This is another technique of um, getting a hand gesture recognition, which is a variable technique when you put up some sensors on your hand, and then you study the or get your hand gestures. So the surface electromyography sensors with the variable devices are the most common hand gesture acquisition tool. So when you want to acquisite your hand gestures, then you may need some kind, if you are not going on computer vision techniques, which means you are not using a camera, but rather you are actually putting some device on your hand, then you the wearable devices are your thing. You may also see in VR games, you put or you hold something in your hand and you do some gestures, so you may wear something. So in VR technology, the wearable techniques for the gesture recognition are also doing good. You need to um, create a focus on which application area you want to focus. So if your main focus is to the human computer interaction, so you are doing something, you are creating a gesture recognition technique so that other people can use that for a human computer interaction as a human input device, just like a keyboard or a mouse. You want your hand gesture recognition technique as a replacement for that input devices. You may want to consider a computer vision based technologies. But if you are doing this for some medical purposes, or where you want to monitor disabled persons or some similar uh, technologies, you may want to consider a wearable devices. If you are going on a VR route, you may want to consider a wearable devices. So if we click a study snapshot for that, This says that technique, applications, and challenges in hand gesture recognition this paper comes up with, and EMG sensors and ANN were the most used tool in hand gesture technologies. And this paper is also had 80 citations, which is pretty higher than the above paper, which has 26, but that doesn't our concern here. It is highly cited paper, so it has a good reputation, and 2019 is the year of publication. And the PLJ Computer Science was the journal where this research paper was published. So we have the next paper, which is a literature review base and recent methods and database in VN base hand gesture recognition. So this come up with all the VN base. So whenever you are doing a VN based thing, this paper which has a good literature review in it, and the number of citations is pretty higher, just like any other review paper. It is cited 248 times, and influential citations are 6, which is pretty good. Compute with image underset. And let's key takeaway. What is key takeaway? That vision based hand gesture recognition method using RGB and RGBD cameras show promise, but unresolved challenges and occlusions issues require further research. So if you want to do a further research, and this is an uh, open-ended question for you, which you can go take to the next level. The paper surveys RGB and RGBD sensors based on hand gesture recognition methods, dynamic as well as static. So, if you are doing a hand gesture recognition computer vision base, this paper would be handy for you. The quantitative comparison of algorithm is done using a set of 13 measures chosen from different attributes of the algorithm and the experimental methodology adopted in algorithm evaluation. We point out the need for considering these measures together with the recognition accuracy of the algorithm to predict its success in real-world application. Paper also reviewed 26 publicly available hand gesture databases and provide the web links for their download. So this paper will really helpful if you are doing machine learning based hand gesture recognition, which is pretty much obvious. If you want to go for a higher accuracy in anything, this database will really help you. 26 publicly available hand gesture databases, so you can cite this paper for that, you whatever database you are using. And there are further breakdown of related research papers. Then we have another gesture recognition survey. This paper is also highly cited 730 times, and the paper explores various gesture recognition techniques, and it is published in International Journal of Computer Applications. And this paper explored various gesture recognition techniques, highlighting their potential for improving human computer interaction and enhancing the virtual environments. Okay, so we have this hand gesture recognition based on shape parameters, which is achieving 94% accuracy using a webcam and 5-bit binary string output. This is also a very good from the algorithm achieved 94% recognition rate for 45 different hand gestures. So 45 is pretty good. Let's see this one. Pattern recognition and gesture recognition are the growing field of research, being a significant part in nonverbal communication, and gestures are playing vital role in our daily life. And what it says, gesture recognition has a wide area of application, including human-machine interaction, sign language, immersive game technology, by keeping in mind the similarities of human hand shapes. Okay, one more thing we can consider is quick search on Google. These are the hand gestures for if you are seeing the list of gestures. Okay, so we have a Wikipedia page which gestures are a form of non-verbal communication in which visible bodily actions are used to communicate important messages. So yes, the gestures could be body gestures, hand gestures, any other thing in parallel with spoken words. Okay. mm, yes, single-handed. So some gestures are single-handed, and the American Sign Language is also very good example, a very good use case. So yeah, you can look into this Wikipedia topic. Around the world, 42 hands, 500 plus hand gesture. Okay, let's go further and let's search for a project, hand gestures project, and the top 10 gesture recognition project for engineering students. We'll break through some. Okay, so yes, the gesture controlled robot. The gesture controlled robot is also a very good project where you control a robot with your hand gestures. So if we play this video, we may see some um, result how this works. These are using our recognition kit, gesture recognition kit. So this is not what I mean. My mean was the focus of the hand gestures with some kind of glove where you're wearing some wearable devices, and but this is using a gesture recognition kit, which could be leap motion based detection, maybe real-time camera. So this is using a MATLAB for a real-time camera and detecting the hand gestures. Recently I had uploaded a MATLAB based skin segmentation video for segmenting the hands for the skin with the skin color, where I discussed the HSV and YCBCR methods for uh, skin color segmenting. This is the MATLAB based code. We may work on this as well and upload a video where we will be dealing with this similar kind of project. They are doing ROI base, will segment the hand and then do the gestures on that. One more thing comes up in my mind that I don't know, I'm not sure what they are doing. Let me check. um, there may be a use case. Let me see if we have a good quality. There may be a use case where we can use, yes, the multiple stages. So Instead of this, these are the different stages they are dealing with. But if we come up with this, I will use it as a motion history. So it comes into my mind that we can use a delay, then we capture the hand, for example, let's say every 2 seconds, then we create a motion history, and then we will see if the compare the motion history with some kind of dynamic time wrapping, which is and template matching the correlation, which is an easiest technique. And this way we can create a very simplest computer vision based dynamic hand gesture recognition system. So yes, if you are doing it just for your semester project, you can consider this kind of approach, which will serve the purpose and easy to implement, and you don't have to bother much. Then we have a deep learning base. Obviously anything you are doing, you just take the image, you train a deep learning model. It is a purely a deep learning based project, so nothing fancy to do for the image processing related thing or any kind of other sensors involved. This is purely a deep learning based project where you collect a data set. You can download an online data set, you train some kind of deep learning model, and then finally you infer them and test on a real world camera stream. So we have a gesture control robotic arm, which is using a pretty much previous approach where we have some gesture recognition kit, and you do some gestures just like you apply the gesture to zoom in and zoom out the pictures in your mobile phone. And like we are using zoom out in and zoom out now, this is a similar thing using a leap motion. So yeah, home automation using leap motion. Leap motion use camera and infrared LED for gesture sensing. So this is also a leap motion base. uh, okay, so human action recognition. Human action recognition is also a project where you recognize the human actions. In this case, if you are doing a computer vision based technique, what you will do, you will capture the complete human image, and then you apply all the techniques for all the human body, the whole body. Here we have another leap motion based gestures.
Test the leap motion budging UI. It helps to show gesture results.
Okay, so let's come back. Let's see this GitHub code. Okay, so we have a Google AI. So we have a Google example. I wasn't aware that Google also has for Edge AI. Okay, so this is also MediaPipe base. MediaPipe gesture recognition task lets you recognize hand gesture in real time and provide the recognized hand gesture result and hand landmarks of the detected hands. Okay. So this is a Raspberry Pi base example, which means that they had used the MediaPipe in the Raspberry Pi. So you do the imports like this. The MediaPipe gesture recognizer task requires a trained model bundle that is compatible with this task. For more information on variable trained models for gesture recognizer, see the task overview. So we have model selection. We download the model, we provide. Okay, so we have a hand gesture classifier pre-trained, which is 192 by 192 or 224 by 224. It which means that it can accept the input image in these formats. The quantization type is float 16, which means it can further quantize to 8-bit. The task also supports the modification of the model bundle using the model maker. For more information using a model maker to customize models for this task, see the customized model. Um, so it has 21 landmarks below. The media pipe returns the 21 landmarks. The hand landmark model bundle contains palm detection model and hand landmarks detection models. Simple palm detection. The gesture classifier model recognize these common hand gestures. Unrecognized, closed fist, open palm, pointing up, thumb down, thumbs up, victory, and love. So if you just use this, okay, so the CPU, if you do with the CPU, then 16.76 millisecond latency, and on GPU it is 20. If you want to improve or alter the capabilities of the model provided in this task, you can use model maker to modify the existing models. Well, to be sure, I never tried the model maker, so I will see this model maker in some other video where I'll totally focus on the deep learning and the machine learning based streaming. But today we are just uh, getting an overview of how many types we can create the hand gesture based projects. The real-time hand gesture recognition using TensorFlow, but my more focus is not using the machine learning, especially the deep learning, because I want to say that if you are learning something or you are doing starting the research, you should first start with basics things and see how much that basic things achieve accuracy. If you go with that route, you will see that if you cover the basics, if you know the bare minimum techniques and their accuracy level, you can easily make efficient models, because you will utilize your resources wisely. You will not waste resources. So if some problem could be solved with a simple basic technique, you will not overuse some machine learning and deep learning models to overkill. Okay, so that benefit will give you considering a simplest approach first. Okay, let's see if we can explore the code. What they say, this guide will teach you how to code a computer vision program that recognizes simple hand gestures, the waving, the pointing, the scissors, fingers extended, the rock. Okay, the easiest way to get this running is to Jupyter. Okay, get it and plan ahead to write the base of the program. To focus on the user's hand, we can use the background subtraction in OpenCV. Basically, we first take a snapshot of the user's background, then we compare all the subsequent frames to the snapshot and check the difference using thresholding. We can highlight the difference between the two images to find the object of interest, so which is ROI. Well, the background subtraction, this is a very good approach for any simplest hand gesture recognition project. Then it is using a simple thresholding. To make the thresholding easier, we can also focus on only a portion of window, which will help with both user comfort. They won't have to stay off screen to use the program, and runtime, since less pixels will be checked for gestures. Okay, for recognizing gestures, I found the simplest strategy is to have a gesture recognizer with two outputs of different priority. One that checks how much the center of the hand is moving and how quickly to check for waving, high priority. So this is a technique for dynamic hand gestures. One that counts the number of fingers extended, then selects the gesture based on the number, low priority. This could be a static gesture, I guess. The priority specs is important since if the user hand is waving quickly, we shouldn't waste time trying to count the number of fingers extended, especially since likely be too blurry to count reliably anyway. Okay, so here we hold the background and hand, we created some variables, then we start the camera with the video capture, and then we run a while loop, and inside the while loop we take a one frame and then we resize it, and then we show that this is simplest approach. And then we remove the mirror effect in the camera with the flip function, and then we will go for our ROI. So they are defining their region of interest, and then they are simply doing a frame counter. I'll wait for So this is very important point which I want to highlight is that if you only take the first frame of the background, you will immediately run into issues due to the lighting condition. So you need to tackle that as well. If your webcam is anything like mine, it spends its first several frames adjusting for shadows, which is not what we want for our program. So remember that frame lapse and calibration time variables from before. This is where they come in handy. I have found that averaging the first 30 frames of the camera input is enough to remove the obstacle of initial lighting adjustment. So let's go to the main function, and immediately after we get the region of interest using get region, write an if statement that checks if we have passed over calibration time. Okay, so because I'm just scrolling this on my mobile phone, I can't show you a live demo, but I'll soon test this code because a lot of things are promising and should work. Then we have segmentation block. They do the background subtraction with the absolute diff function. Then they apply a thresholding, simplest thresholding, and then they do a contour analysis. If they don't get anything, they say the hand is none. But if the hand is in frame, they segment the region and return that hand. Region pair, then the hand is shown in this image. After that, they recognize when user is waving. The first gesture we can get our program to recognize is waving. It's easier than counting fingers and also has higher priority compared to disfering finger-based gestures. How do we do that? Now that we have the image segmentation function, we can get an isolated image of the hand. We can take that isolated hand shape and find its highest and lowest x and y values. So we can find the center. And if the center point is moving a lot in a short amount of time, the user is waving. So that's pretty good algorithm and simplest to implement. This is a good thing if you just want to check the waving, which is a good example of a static, dynamic gestures. Program the system to get the hand center point. Then we create a convex hill or static hand gestures. Then we do create a function for hand data to check for waving, and you are good to go. Check for waving. The center point, you create a previous center point, then you get the current center point, then you take the absolute difference, and if the difference is greater than 3, which means that they had changed, the hand is waving true, otherwise it's false. So that simple function could give you an estimate that the hand is waving. Then what we can do, we can draw the contour and get hand data, and we can predict that hand is moving. Coming for a static part, you can count the fingers using convex hill. You can draw a line, contour analysis, count the fingers by making sure the contour lines are finger sized. This prevents a rock gesture from being mistaken for fingers. So this is saying that you should check that the contour are at least finger height. So if you close your fist, which is a rock gesture, is not considered as a fingers. Otherwise, all the contours are your fingers. You can count them and create a list of gestures to choose the most frequent one. Yeah. So this could be the reason, because your code is um, very fast. You could come up with multiple outcomes, which is a pretty common when you're doing the image recognition tasks, the computer vision based techniques. Then what you should do is get the most frequent predictions, and you create a list, you append your prediction in it, and every 12th frame they make some 12th and predict that. Here you can see the pointing, the scissors, the rock, and the waving, and the gestures are working pretty well in this case. This is a good simplest approach which you can use, and it is pretty good for a basic OpenCV Python based hand gesture recognition system. In a demo video, I will use this code. I will make some tweaks to improve it a little bit, because I will segment the hand rather than a pure binary threshold system. Will be all for today's stream, I guess. See you in the next one. Thank you.